In this video, we try to solve a so-called dry mixture problem by using linear equations. Let's take a look at this specific example. A store sells regular coffee for $7 a pound and a gourmet coffee for $12 a pound. To reduce the inventory by 30 pounds of the gourmet coffee, the shopkeeper plans to make gourmet blend to sell for $9 a pound. How many pounds of regular coffee should be used? The principle of dry mixture problem depend on the following: the total value of the merchandise before mixing and the total value of the merchandise before mixing, after mixing should be same. So let's take a look here. What are the values? Normally we try to use a table to write everything we needed. Okay, because this case we want to find out how many pounds of regular coffee should be used. First, we're going to assume that X is the amount of regular coffee. So here. And so now let's set up a table. So here we're going to do the following. So here. Okay, so here. So we put a price here, and that's the amount, and that's the value. So this is regular coffee. That's the gourmet coffee. And that's the mixture. So regular coffee, the price is $7 per pound. And amount, we do not know, but we call this as X. So the value of the regular coffee is $7 times X. The price times amount give you the value of the regular coffee. The gourmet coffee is price is $12. And amount, so here it says to reduce the inventory by 30 pounds of gourmet coffee. So that is 30 pounds. So the value is going to be 12 times 30. So the mixture, so the so-called gourmet blend, that's mixture, and the price is $9. So the amount is obviously that's regular coffee plus gourmet coffee add together is the mixture's amount, which I got X plus 30. So the total value will be 9 times X plus 30. As we mentioned earlier, total value before mixing, which is this two add together, and it should be equals this mixture's value, that is after mixing. So what we have here, we write the equation as this here, before mixing, and this is the regular coffee's value plus the gourmet coffee's value, and that equals the mixtures, the amount of the mixture is X plus 30, X plus 30. So here is $9 times X plus 30. So now we have a linear equation. All we need just to solve this linear equation. Go ahead to simplify distribution. Okay, so here now let's go ahead to subtract 7x from both sides and subtract 270 from both sides. So that will give us the following 9x minus 7x, which is 2x. That's cancelled, 360 minus and 270. That's give us 90. So solve for the x, both sides are divided by 2, so that is 45. So let's check here, okay, before we answer the question, we check. So 7 times 45 and plus 12 times 30. This is a total value before mixing. Okay, so we find that that's actually equal to 675. And because this is 315, this is 360. Okay, add together is 675. And so that's the before mixing the total value. The after mixing is 9 times x plus 30, so which is 9 times 45 plus 30, which is 9 times 75, which is also 675. So that's 2 equal, left side equal to right side. Okay, so also from here we can see after we verify this, that's also satisfied the problem's conditions there. It makes sense there. So now we're gonna answer, we're gonna say, and we 45 pounds of regular coffee should be used. Okay, that's what we have here for first question. That's normally how we solve a problem there. We have to list all the merchandise and forgot the price and the amount, then values. Make sure before mixing the total value should be equals after mixing and the total value. So then you have equation. Start up equation, you solve the equation. So let's take a look at next questions. Next question is similar. So here we have the problem. That problem says 15 pounds of trail mix. So 15 pounds. So here, that's 15 pounds of trail mix are made by mixing 2 pounds of raisins worth $3 per pound with peanuts worth $4 a pound, M&Ms worth $5 a pound. How many pounds of peanuts must be used if the mixture is to be worth $4.20 per pound? Okay, so here because it asks how many pounds of peanuts. Okay, so here we're gonna say X pound of peanuts. So here X equals the weight of peanuts. And notice here, we don't know the weight of peanuts. We also do not know the weight of M&Ms. So in that case, if we can figure out the weight of peanuts, obviously we can figure out the weight of the M&Ms. So now we have 3 different goods there. So now we're gonna put it in the table. Okay, so here, let's take a look here. And the first we have this is a raisin. And then we have peanuts. When we have M&Ms. And this is the mixture, okay? And the price here, raisins is $3 per pound, peanuts is $4, M&M is $5, okay? And the mixture is $4.20. And the amount for each can of raisin is 2 pounds. And the peanuts is X pound because we do not know, say X is the weight of peanuts. But M and M, we also don't know. But since we already know this 2 pound, this is peanuts is X pound, the M and M, so it means 2 plus X plus the weight of M and M equals 15 pounds because 15 pounds of a trail mix. So that means in the M and M's, okay, that weight gonna be 15 minus 2 plus X. Okay, so 15 minus, and that's weight, M and M's weight equal to 15 minus 2 minus X, which is 13 minus X. So that's 13 minus X. And the mixture we know is 15 pounds. So the values. And raisins value is 3 times 2. Peanuts value is 4 times X. M and M value is 5 times 13 minus X. And the mixture's value is 4.2 times 15. So now, this case, there's 3 different goods here. We put this together. The total value is this value plus this value plus this value. That's before mixing. Each of this value add together is total value equals the mixture's value, which is after mixing. So now we have our equation. So here 3 times 2 plus 4 times X plus 5 times 13 minus X equal to 4.2 times 15. So that's the value of raisin, value of peanuts, value of M&Ms. And that's the mixture's value. So before mixing, you list each value. Okay, now add all those values together. That equals the mixture's value. Okay, go ahead to simplify and to solve this equation. That 2 times 3, 6 plus 4x plus 5 to distribute to each of them. We have 5 times 13 minus 5x equal to 4.2 times 15, okay, which I got is 63 there. Combine the like terms. 4 minus 5x, this is negative x. 6 plus 5 times 13. 5 times 13, which is 65. 6 plus 65, which is 71, equal to 63. So now subtract 71 from both sides. So you have negative 1, negative x equals 63 minus 71, which is negative 8. So x equal to 8. Okay, so that's we got 8 pounds of peanuts. But let's check here, see if this makes sense here. The left side, so here 3 times 2, 4 times 8, 5 times 13 minus 8. So we have 3 times 2 plus 4 times 8 plus 5 times 13 minus 8. So that gives us 6 plus 32 plus 13 minus 8 is 5. 5 times 5 is 25. And 38 times 20, that's 38 times 25, which is 63. And you can see here we already know the right side is 63, so they are equal. So now we know, and that's the equation, that's x equal to 8 is solution. Also makes sense, satisfied the problem conditions there. So now we're going to answer, we're going to say, in 8 pounds of peanuts must be used. And so you can see after we got 8 pounds of peanuts, and we also know, so here you can forget the M and M because you have 2 pounds of raisin, okay, 8 pounds of peanuts. So that means you only get 5 pounds of M&Ms. Although it does, okay, it didn't ask us about the weight of M&M, but as I mentioned, if you can figure out the peanuts value, so you can figure out the M&M's the weight too. Okay, that's the end of uh, this kind of problem. Okay, so remember the main principle is the total value of the goods before mixing and should be equals the total value of the mixture. Okay, so that's all we're gonna use to set up an equation like this called dry mixture problems. Okay.